Hello, we're on 4.04 Algebra 2 today, and our lesson today is on solving exponential equations. And to do that, we're going to be getting the same base. So first of all, with an exponential equation, I'll write this out, exponential equations, it means that your variable is in the exponent. So we're trying to solve for a variable that is all the way up in the exponent. So to do that, we're going to first try to get the bases to be the same. And eventually we're going to talk about another method, which is using logarithms to solve these as well. Get the bases to be the same. And when you do that, just a note here, you always want to try to change the bigger one first. All right, step number 2 is once your bases are the same, you're going to set your exponents equal. And then you're going to solve. So what this is kind of saying here, or what it is saying, is if I had 2 to the x, and then I said, well, that's equal to 2 to the third. What's the value of x? Well, if they both have a base of 2, then I know they have to equal each other. 2 to the third has to equal 2 to the third. So x would equal 3. So once you have the same base, you know that your exponents are going to be equal to each other. If you had 5 to the x equals 5 to the 7th, what would x be? Well, x would equal 7 because they both have a base of 5 and their exponents have to be equal then because those two values must be equal to each other. So now if you had 2 to the x plus 2, and you know that's equal to 8 to the x. Not as easy as what I just showed you because they don't have the same base. So here's where you want to take this bigger base in step number 1 and try to change that so you can get it to have the same base as the other side. So you want to think to yourself, now you're thinking in exponents, not multiplication. So you want to think, what could I rewrite 8 with as a base so that when I raise it to an exponent, it'll give me 8. And I want to try to do that with a 2. So I think to myself, okay, well, 2 squared is 4. 2 to the third, 2 to the third is 8. So I'm going to take this 8 and I'm going to rewrite it as 2 to the third. So I took just this 8 and I replaced it with 2 to the third. And then I'm going to bring down my exponent of x. So again, this 2 to the third is the same as the 8. I didn't change the equation at all. It just made it look a little different because now instead of writing an 8, I wrote 2 to the third power. So you don't want to do 2 times 4 because that does give you 8, but we want to rewrite it as an exponential with the same base. Once I now have the same bases, now I can kind of just like cancel those bases out and look at the exponent like we did up here. Once you have the same base, we know the exponents are equal. So now I know x plus 2 equals 3x. And now I'm just going to solve for x. So I'd subtract my x over and then divide by 2 to get x equals 1. Also, great thing with these is that we can check them in our calculator. So anytime you have variables and an equal sign, we can use our y equals. So my y1, I'm going to type in my left-hand side, which is 2 to the x plus 2. And for y2, I'm going to type in 8 to the x. I'm going to go to my calculator and type those in. So I've got 2 raised to the x plus 2 and then 8. You always want to check the original as well. Oops. X. Okay, and now I'm going to just go to the table and I'm going to check. If it helps, just do second window, start your table at whatever your answer is. So I got x equals 1, so I'll start it at 1. So now it should be my first entry there. What did I, oh, and it didn't check, so I made a mistake, which I didn't catch before. Had an extra 2 here. And now we see that it checks. So the first entry is x equals 1, y1 is 8, and y2 is also 8. And to show that check, you would just show that entry in the table. So at 1, and as soon as we see y1 and y2 are the same, it means they intersect there. It means those two equations are equal at that point because they have the same x value of 1 and they have the same y value of 8. Let's try another one. So this one is 4 raised to the x plus 3 equals 32 raised to the 5x. So here are the questions you should be asking yourself. Number 1, you want to look at the bigger base. So we'll say, can I rewrite 32 with a base of, and I'd like to write it with a base of 4. Because if I can write it with a base of 4, then I can get them to have the same exponents. So then I go here, and if you don't know your powers really well, you can always go to your calculator. You can say, okay, 4 squared is 16. You probably know that one, but maybe you don't know 4 to the third. Oh, 4 to the third is 64. I need this to equal 32 with a base of 4. So I went 4 squared is 16, 4 to the third is 64. I passed 32. Again, we're not dividing by 4, we're raising it with an exponent. So that didn't work. So now I want to ask myself, can I rewrite 4 with a different base? So the 4, I'm looking at the left-hand side and say, okay, well, I can't write 32 with a base of 4, but maybe I can change both bases now. And the answer to that is yes, I could rewrite 4 is equal to 2 to the second. All right, so if I can do that, can I rewrite 32 with that same base? So in this case, a 2. So you might need to go to your calculator. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. Not quite there yet. 2 to the fifth is, 32. So, and a lot of you might not need to put that in your calculator, but if you do, that's exactly how you can do it. So then I could say, yes, I could rewrite 2 to the fifth is the same as 32. So we're going to change both bases in order to get them to have the same base. So I'm going to take 4 out and rewrite that as 2 squared. And then you're just going to bring down that exponent, because when you raise a power to a power, you powerply. So you're just going to multiply them. So right here, 4 is the same as your 2 to the second. Equals, I'm going to take 32 and rewrite that as 2 to the fifth. So 32 is the same as 2 to the fifth, but I still need to have that 5x there. So I'm going to bring that down. Again, power to a power, we just powerply or multiply. So we bring that as 5x. So now I have the same base. They both have a base of 2. So the green circles are what I replaced. I took out the 4, replaced it with 2 squared. I took out a 32, replaced it with 2 to the fifth. So now, once I have the same exponent or same bases, I can set my exponents equal to each other. So I have 2 times the quantity x plus 3 equals 5 times 5x. And then from here, you're just going to solve. So we have 2x plus 6, we distribute, equals 25x. Subtract your 2x. And divide by 23. So we get x equals 6 over 23. And then let's go ahead and check that in your calculator. So pause the video and see if you know how to check that on your own. So you should have y1 equal to 4 to the x plus 3. And you always want to check the original. y2 is 32 raised to the 5x. Go to your table. We'll type in 4 to the x plus 3. Here we're going to type in the right-hand side, 32 raised to the 5x. And then second window. Now this one is really important because the answer is a fraction. You have to do second window if you're going to use your table to check it. You, of course, could do second trace intersect as well to see where they intersect, and then it would give you the decimal. So now I'm going to go back to my table, and now it should start right at that fraction, and you'll see y1 and y2 are exactly the same, 91.884. And since those y1 and y2 are the same, we know that they intersect there, that they're equal there, telling us that it checks. X is equal to 6/23. Okay, next one. 81 raised to the x plus 1 equals 27 raised to the 2x plus 3. Pause the video here and see if you can try to get these two to have the same bases. Remember, when you do that, always try to look at the larger base first. See if you can rewrite it with the smaller base. So see if you can rewrite it with a 27. If not, then try to go smaller for both bases. All right, go ahead and try that. All right, so first I maybe tried 81 with a base of 27, and you probably know already without trying it, but if you didn't, you could always do 27 to the second and say, whoa, 729, that's way too big. I only want to get an 81. So then maybe I go to the 27 and say, can I write that with a different base? Or even if you look at the 81, a lot of you are probably thinking 9. Well, if I think about 9, 9 squared is 81. Could I write 27 then with a base of 9? And the answer is no, because I already passed 27. 9 squared, we're already at 81. 9 to the first, we're just at 9. So there's no way to write 27 with a base of 9. I could do 27 divided by 9, and I know 9 times 3 gives me 27, but that doesn't help us here. So let's see if we could write them with a different base. So what other base could I rewrite 27 with? Well, we can't do a 2, maybe a 3. So if you do 3 squared is 9, we know 3 to the third, oh, that's 27. So can I write 81 with a base of 3? So then let me try 3 to the fourth. Oh, and that's 81. So that means I can write both of them with a base of 3. So 81, this right here, I'm going to take out and rewrite as 3 to the fourth. And then I'll bring down my x plus 1. Then I'm going to take out my 27 and rewrite that as 3 to the third. And then bring down my exponent of 2x plus 3. Once I have the same bases, they're both a 3, now I can set my two exponents equal and solve. So if you needed help on that one, pause here and solve that equation. And when you solve it, you want to make sure you distribute, and you should get x equals -5/2. Now pause the video and do your check. So you should have had 81 raised to the x plus 1, y2 is 27 raised to the 2x plus 3. And then in your table, you should already see that they check. But again, to do it in your table, you want to start your table, go to second window, and this time you would start your table at -5/2. The alpha y equals button doesn't work here, by the way. You just have to do the fraction. And you should get something like 0.00137, and you should get that for both, so we know that they check. Next one is 10 raised to the x minus 3 equals 100 raised to the 4x minus 5. Pause the video, try this one on your own. All right, so you should have seen here that always look at the bigger base first. I can rewrite 100 with a base of 10. So 10 to the second gives me 100. Now my bases are the same. Set your exponents equal. And you should get x equals 1. On your papers, you should be showing me that work. And then you should also be showing me the work for your check. So if you haven't checked it already, pause the video, fill all that information in there, and that should all be in your notes. Next one, 3 to the x squared equals 9 to the x plus 4. Pause the video and see if you can do this one on your own. If you're struggling, you can come back, but at least you should be able to get those bases to be the same, and then it's the same process from there. So give that a try. So again, we're going to look at the larger base first, which is a 9, and say, can I rewrite it with a base of 3? Because that's what I have over here. And I know 3 squared gives me 9. So I'm going to take out the 9 and rewrite it as 3 to the second and bring down my x plus 4. Once I have the bases the same, so they're both a 3, now I set my exponents equal to each other. From here, you should distribute your 2. And now I have an x squared and an x. Anytime I have an x squared and an x, I want to get it equal to 0. And you want to keep x squared positive. So I'm going to subtract over my 2x and subtract over my 8. And then once you get it equal to 0, you should factor. Pause the video if you haven't done this yet and do this one on your own. All right, so here I have x. I need to multiply to -8, add to -2. That's going to be -4 and +2. Then set each of those equal to 0. So here I got 2 different answers that I'm going to need to check. Oh, sorry, I didn't jump the gun a little there. X plus 2 equals 0. Always show that. And then you can say x equals -2. All right, pause the video and write out your entire check for these. And so here you should be checking both -2 and +4. In your check, your -2, you got your 2 values there, should have been fine. I will say on this one, it looks a little bit funky. So you get 4.3E7, but you also get 4.3E7 there. And that's fine. That's just using scientific notation because the number's too large to fit in the calculator. So we do that. All right. Next, let's try another one. 6 to the 7x plus 4 equals 36x squared. And pause the video there and solve for x. All right, so for this one, you're going to rewrite 36 as 6 squared, bring down your x squared, set your exponents equal to each other. And again, we have an x squared and an x, so we want to get that equal to 0. We want to keep x squared positive, so I'm going to subtract the 7x and the 4 to the other side, to the right side. And now I look for a GCF. I don't have one. Once we get x squared and x equal to 0, then we need to factor. And since there's a 2 in the front, you want to use, you guessed it, P's and C's. So pause your video and do your P's and C's. It is very important that you can do your P's and C's on your own right now. So please do so. All right, I am going to go over it because in case anybody's struggling, I want you to have it. But if you needed to use this video right now to do P's and C's, pause it and redo it completely on your own. This is something you need to be able to do at this point. All right, so P is the product of my first and last term, 2 times -4. My C is -7. Then I'm going to split the middle, so blank x minus 4. I keep the first and the last term the same. I'm looking for 2 numbers that have a product of -8 that combine to -7. So that's going to be, and if you don't know, go to y equals, type in -8 divided by x. -8 and +1. So I put those on my lines, doesn't matter which line. And then I factor out my GCF from each set. So I'm going to take out a 2x, which leaves me with x minus 4. And then the second set, there's no GCF really, so I'm just going to take out a +1, which means nothing changes inside of there. Once I do that, my two parentheses should be exactly the same. And then my leftovers will go in the other group. So now those are my two factors, but I want to solve for x, so I'm going to draw my line and then set each factor equal to 0, and then solve for my 0 values or my roots. So I get -1/2 and +4. Pause the video here, write out your check. I do want to see these checks written out on your notes. So go ahead and do that. For both values, again, you should have two different entries in your table at -1/2 and +4. And for -1/2, you will have to do this second window to start your table at the fraction of -1/2. All right, number 7. 5 to the x equals 1/25. See if you can try to think through this one on your own and try this to solve this one. It's a little bit different, but see if you can think of a way to solve it. All right, so this is different because we have this fraction here. So what I would say is try to think, how could I rewrite 1/25 with so that it's not a fraction? And remember, negative exponents are the exponents that tell us to flip or take the reciprocal. So 1/25 is really the same thing as saying 25 to the -1st. So now that makes it a little bit easier for me to look at. So now I want to rewrite 25 with a base of 5. Well, I can do that because I know 5 squared gives me 25. And then bring down your -1. Set your exponents equal. So x equals -2, and we're done. Now take a minute, pause the video, show me your check. Again, left side y1, right side y2. And then check out your answer, which is -2. All right, and hopefully that checked for you. And I'd like you to solve this one now. So 4 raised to the x plus 5/2 equals 1/2 raised to the 2x plus 1. Pause the video and solve this one on your own. Okay, so again, just like with the last one, I would start by rewriting 1/2 as 2 to the -1st. Now you have an easier time looking at these. So now take your 4 and try to rewrite that with a base of 2. Pause the video, rewrite that, and then I would like you guys to solve that on your own and check it. And I will be looking for all of that work that is completed by you. So your final answer should be x equals -3/2 or -1.5. Decimal or fraction is fine there. And then I should also see your check at -1.5 or -3/2 for that as well. All right. And that is it for us for today. If you have any questions, please make sure you let me know. If you had any trouble, go back and try to redo some of these completely on your own as well. And pie out.